I'm going to do just a couple examples from 5.4 through 5.6 as a way of reviewing. So here's some of the topics that we worked through. We're able to look at a quadratic in standard form and rewrite it in vertex form by completing the square. And then we're going to identify the stretch factor and the vertex from doing that. So if you recall, this is vertex form. It looks like this. F of x equals a times quantity x minus h squared plus k. So I want it to look like that. So we are going to factor out the 4 from the x squared and the x. So I divided both those by 4, and then I'm going to complete the square to create a perfect square trinomial and be able to factor this part. And then remember, when I do it on the same side of the equal sign, if I'm adding something here, I have to subtract it here so that I'm really keeping the equation balanced. Okay, so completing the square, b over 2 here is -8, squared is 64. So this 64 though is being multiplied by 4, so when I compensate over here, I also must multiply it by 4. Okay, oh, and I left k in there, you guys. K in this case is the, right now, 210. Okay, so now this part factors into b over 2, which was -8 squared, okay, and then 210 minus 4 times 64 is -46. All right, so now it is in vertex form. So from here, the vertex is 8, -46, and the stretch factor is 4. Okay, so we reviewed this actually in the 5.5 video, but these are the different methods we have for solving quadratics, and this is just to help you be more efficient. If it's easy to factor, that is the quickest and most efficient way to use the zero product property to solve. If there's no x term, the square root method is the most efficient. If a is 1 and b is even, completing the square is, and then if it's none of those, the quadratic formula is the best method. So let's try and use the most efficient. So here, a is 1 and b is even, so I'm probably just going to complete the square here because the constant is already on the other side. So x squared minus 6x plus b over 2 squared, we're doing it on both sides, so I'm going to add the same thing to both sides. B over 2 squared here is 9. Okay, so I get x squared, factor, b over 2 is -3. Okay, and then -12 plus 9 is -3, square root both sides. We also have been working with the complex number system and imaginary numbers. So here, square root of 3 can be written as square root of -1 times the square root of 3, and square root of -1 is I, our imaginary unit, so I can write it that way. And then isolate x by adding 3 to the other side. So this one has 2 imaginary solutions. Okay, this one, there is no b term, so I'm going to just use the square root method and get x squared by itself. So I get x squared equals -18 fourths square root. So x equals plus or minus. Again, we have square root of a negative, so I know I can pull out the I. I'm going to write it like this for right now. Square root of 18, square root of 4 is just 2. Square root of 18, though, I can break down into 9 times 2. So I can pull out a 3. So we have x equals plus or minus 3i root 2 over 2. All right, last one here. So I have 3x squared minus 4x minus 6 equals 0. I'm not going to complete the square on that one because a is not 1, and not all of those numbers divide nicely by 3. I can check, is it easy to factor? So 3 times -6 would give me -18. So 3 and 6, 2 and 9, it's not appearing to be a great factoring one. So I'm just going to use the quadratic. So my a is 3, b is -4, and c is -6. So we got -b plus or minus b squared minus 4 times A times C all over 2 times A. Okay, I'm going to simplify what's under the square root here. So we have negative 4 squared minus 4 times 3 times negative 6. So we get 4 plus or minus square root of 88 over 6. So this one's positive, so we are going to have 2 real solutions. So square root of 88 we can break into 8 times 11. 8 we can break into 4 and 2. So we can pull out a pair of 2's. So we got 4 plus or minus 2 root 11 times 2 is 22 over 6. All 3 of those I can divide by 2, so I get 2 plus or minus square root of 22 over 3. Alrighty. Now this last part, you guys, I just want you to be aware this is a formula we've worked with quite a bit when we were graphing, is the axis of symmetry. X equals negative b over 2a. So that can be useful if the equation is in standard form. You can just do negative b over 2a, get the axis of symmetry, and then whatever you get for that number, you plug it back in to get the y coordinate of the vertex, okay? Or an option is also to complete the square. And completing the square is nice because it gives you the vertex in that form once it's completed. So both are options for finding the vertex. They're just 2 different ways to do it. Axis of symmetry is one way, or completing the square and then looking at that equation to get your vertex is also an option. All right. Okay, in this one, we're just going to review simplifying negative roots, okay? So remember, square root of negative 1 is I. So I'm going to break 28 into, I'm going to pull out the I right away. So then I have 4 and 7, and we can break 4 into 2 and 2. So I can also pull out a 2 out front, and then the 7 stays underneath. So this would be 10I times the square root of 7. This one, negative 144, so I know the square root of 144 is 12, square root of negative 1 is I, so we have negative, because I have that negative out front, 12I. Conjugate, okay, recap of what that means. It's the same complex number, A and B are the same, but we change the sign in the middle. So this becomes negative 7 minus 8I. This one, I'm going to write it in our standard form, so A plus BI, okay? So the real part comes first, then the imaginary, so this would be 4 minus 2I would be the conjugate. All right, use the discriminant to identify how many solutions. So discriminant, b squared minus 4ac, so I need it in standard form. So here my A is 4, B is negative 6, C is 10. So b squared is negative 6 squared minus 4 times A times C. And then we're checking, is it positive, negative, or 0? So plug that in here. So I have negative 6 squared minus 4 times 4 times 10. I get negative 124. Which is obviously negative, less than 0. So remember, this isn't asking me to solve, it's just asking how many solutions. So if we get a negative value, this is no real solutions, but we're actually going to be more specific. Because it's a negative, we're going to have 2 imaginary solutions.